So we'll learn about general method for finding integrating factor, right? So what is important, if mdx plus ndy is non-exact, then if my minus nx divided by n is equal to function of x, then this part is an integrating factor, right? So example is say x cube dx plus x square dx plus x cube dy is equals to 0. So this is an differential equation. Del m del y is equals to 0 and del n is equals to 3x square. So this is not exact. So del n del m del y is non-zero equal to no del n del x. So this differential equation is non-exact, so its solution is integration. So its integrating factor will be equals to my minus nx is equals to what is most important is what we have and what we are trying to calculate. So x square dx plus x cube dy is equals to 0, and what we have actually my minus nx divided by n is equals to my, that means 0 minus nx thrice x square divided by n x cube is equals to minus 3 by x is equals to function of x alone. So e to the power integration fx dx is an integrating factor by that rule. So this implies e to the power integration 3 by minus 3 by x dx is an integrating factor. So it is equals to minus 3 log of x. So it is equals to e to the power log of x to the power minus 3 is equals to e to the power log of 1 by x cube is equals to 1 by x cube is an integrating factor, So that's it, right? So in 1 by x cube is an integrating factor, that is multiplying by 1 by x cube we'll get, and we'll get an what is called exact differential equation. We'll learn another rule. So that will be certainly rule number. So that will be rule number 2, which will say that rule number 2, that is if say my minus nx divided by it is m is a function of y alone, then integration e to the power integration fy dy is an integrating factor. So these two methods are very important and they are used in many cases, and they are came in exams as an example. So that's very important. So we'll learn about first degree differential equation. Say first degree differential equation. Say we will have dy dx plus p of y is equal to q of x is called a linear differential equation, and it is non-exact. Then its solution is given by y e to the power integrating factor is e to the power integration p dx, and the solution is y into integrating factor is equals to whole integration q into integrating factor dx plus c. Y dot integration p dx is equals to integration q into e to the power integration p dx p dx into dx plus c. So that's what is that's what which is required solution, which is the required solution of differential equation, right? That's it. Important to note that this equation is linear equation because y dash is not involved, and this p is a function of x. So first degree linear, we can say linear differential equation, we can say that linear differential, because now there are certain equations which can be reduced to the linear differential equation, which are not in the form of linear differential equation but can be reduced, right? So in that case we'll say equation reducible to equation reducible to linear differential form. Linear form, that means simply linear form. So what is important is that say our equation is of the form f dash of y dy dx plus p of x of f of y is equal to q of x, where p and q are function of x alone or constant, right? So putting f of y is equal to v, so that what we'll have, f dash of y dy dx is equals to dv dx. So that's what is important. Then equation 1 becomes dv dx plus p of x into v is equal to q of x. So this is important, which is linear in v, right? So that's what important in this. So that is important, and from here we can go through the concept of that is what we will have is Bernoulli's equation. So Bernoulli's equation, we at the same time we can study the Bernoulli's equation, which is quite interesting and quite important. Bernoulli's equation, right? Bernoulli's equation, which says that this is we took particular values of this f dash y dash px fy and qx, right? So what is Bernoulli says that it is of the form dy dx certain, right? And p of x and y is equals to q into x into y to the power n. So where n is not equal to 0, 1, so this is the Bernoulli's equation, which is Bernoulli's equation can be solved by putting v is equals to y to the power n minus 1 minus n, right? So that's what is important, right? So that's what is important for us. So